This is our lesson on the history of the atmosphere. So this takes our atmosphere from the beginning of when the Earth formed all the way through today. Okay, so we know through chemistry, we know through the work that physicists do, we know through study of rocks, all of these different fields of science have all tried to figure out how old the Earth is, and they've all decided on the same answer. It's about 4.6 billion years old, give or take. And so we can see that is what it looks like and how old the Earth seems to be, just from what we see. But the Earth started out kind of like a fiery mess. Okay, as the planets were forming, as the sun had just formed, as these planets were forming, basically there's just all these rocks slamming into each other. All this stuff was happening. And the planet had captured a lot of gas as it was forming. And so as this planet starts like crushing down in on itself, as gravity got heavier and heavier, volcanoes, huge volcanoes, started giving off lots and lots of gases. And that made up the first atmosphere. Volcanoes released the gases from inside the Earth. So these gases spewed up out of volcanoes and made the very first atmosphere. This was 4.6 BYA. BYA stands for billion years ago. And the composition of that atmosphere was methane, carbon dioxide, water, and nitrogen. So there was no oxygen in the first atmosphere. Okay, so as time goes by, we go from 4.6 billion years ago to 4 billion years ago. 600 million years go by. The Earth goes around the sun 600 million times between here and here. Well, the Earth at this point is so hot, it can't have liquid water on it. Liquid water would steam up and boil off into a gas. So it takes 600 million trips around the sun, or 600 million years, for it to cool down enough for the hydrosphere, or the water cycle, to start forming. So, moving on, we have 4 billion years ago. Another billion years go by. So the sun goes around, or the Earth goes around the sun another billion times before we start having organisms that do photosynthesis use carbon dioxide and then start releasing oxygen. So we first start getting oxygen here in the atmosphere. Now on your notes, you have a long arrow going down the side over here. During the length of that arrow, algae is the only life on Earth. Okay? It's a long time period between where that arrow starts and where that arrow ends. Way down here by 500 million years. But algae is the only life on Earth. Okay? So 3 billion years ago, we start getting oxygen in the atmosphere, and things kind of keep going from there. We go from there to 2 billion years ago. Over this whole billion-year time period, we just have algae living on Earth. Eventually, you get enough oxygen in the air that ozone naturally forms in the atmosphere, making life outside of the oceans possible. Now, as someone who lives outside of the oceans, I appreciate this. Ozone is pretty great. All right, excuse me. It makes life outside of the oceans possible by shielding ultraviolet light. So, at 2 billion years, we start getting the ozone layer. But, over the next billion years, everything pretty much stays the same. Okay? Algae is the only life on Earth until we get to about 500 million years ago. Okay? And 500 million years ago, a couple things happen. Up until this point, there's probably only a few types of life on Earth. Mostly algae, it's all living in the water. But eventually, simple multicellular organisms appear. We are multicellular, but we are not simple. Simple multicellular organisms appear. Now, on this time scale, we got to compress things. Simple multicellular organisms appear. Maybe there's only 100 different types of life on Earth at one point. What happens next is really amazing. What happened was called the Cambrian explosion. And the Cambrian explosion, before the Cambrian explosion, we were only seeing about 100 or hundreds of types of organisms. Then, all of a sudden, this Cambrian explosion comes along, and it goes from hundreds of types of things that are alive to millions of types of things that are alive. Life basically explodes in diversity very, very quickly, just 500 million years ago.